Hello. Just waiting for Jackson to materialize. He was working on his munchies. He should be here shortly. I will just report on a really fascinating little side issue that just materialized out of the nowhere. There was a posting on Twitter of this A.N. Wilson who had just put in an attack on Darwin, that he should need to be exposed as the fraud he is, in the Evening Standard over in London. To blunder into punctuated equilibrium and the reptile-mammal transition. I'm adding that to hashtag tip. This is a guy who apparently can't figure out that it's not 1970 anymore, and he needs to update the source material. There, I see Jackson.
How you doing?
Oh, pretty good there. Through my latest stack of material to get through. Proceedings of the National Academy of Sciences. A bunch of really neat new papers, as usual. I still haven't hit Science and Nature yet, and I was just typing about this thing I found out about on Twitter from this British anti-evolutionist who's going after Charles Darwin and his racism and support for the things that lead to Nazism. His theories are wrong, and it's in the Evening Standard over there in Britain, which shows that people in England can suffer from cranial blockage of the rectum just as easily as people in Seattle can, you know?
Well, it's going to go that way, yes.
Okay. 15 years ago, right? Yeah, Paleogenomics says in the side comment. I think that pretty much
I just saw that. I was
it.
like, what?
Yeah. Let me make sure I got the things okay. A problem is about light. Whoops. God, I hate it when I click on this thing and it suddenly goes full screen on me without my asking. So we are going to discuss, yay, historical science, and I guess old Chucky Darwin and a few little other things. So start off then, Jackson, with what your perception is about what historical science means. Is it like we read things in like history books?
Actually, if you type in historical science in Wikipedia, it takes you to the history page. So,
I imagine so. I'm getting a little bit of garbling from your microphone. I hope that's
hello.
Not
Can you hear me?
Something from my end.
Hello. How do I sound?
Oh yeah, I'm hearing you. It sounds like, but I don't know what. Are you hearing me? Okay.
Yeah, I can hear you fine. I'm not even echoing on this time.
It's just like a little raspiness. It's perfectly intelligible. It's not like roboting or anything. Yeah, there we go. I will do my own imitation here and talk like this myself. Anyway, yeah, for my mind, I put the little tag up that historical science is everything that happens in deep time, as opposed to that observational stuff that the creationists go after all the time. And because it's happening, you aren't able to supposedly observe it directly. Well, that means it's kind of iffy now, isn't it? But first off, I like to point out we actually have time machines that we can make use of in the sciences. The really neat one is called a telescope, because we get to literally look back into time with our telescopes. It's literally past. In fact, we cannot observe anything except the past with our telescope. So we get to see the moon as it was a couple light seconds ago. We get to see the sun as it was 8 minutes ago. We get to see the outer planets the way they were hours ago. We get to see Polaris as it was 400 years ago, Andromeda as it was 2 million years ago. So that's one where the idea that you don't get observations that way, astronomy is nothing but that. But the fun part comes in when you deal with what they normally think of is geology, paleontology, and all of that stuff. Yeah. And I would contend. Oh, jump in.
Oh, I was just going to. You go ahead. I'll jump in at the end.
I was just going to say that we do have little itty bitty circumstantial time machines, because I come from a historical background where we notice that all the time. I can't get into a time machine and go back and look at Julius Caesar or Cleopatra.
But how do we know Julius Caesar existed? Ha ha ha.
Yeah, how do we know? We don't have any bodies to look at. We don't have any DNA. Caesar was burned up in the funeral pyre. Therefore, we would literally have no material. It's not like we can literally dig up the bones of the Tsar and do DNA analysis on the bodies at Ekaterinburg. And so we can do actual inputs that way. But the point is...
Oh, yeah. Yeah, I agree. I was just going to say that it's. I think it's funny that Caesar is used by a lot of the apologists as saying, find someone who's better or is like someone who's as well documented as Caesar. It's like, well, actually, there were coins made in his life during his lifetime that are
much
of him.
better. Yeah, we don't have much for when they're trying to do it with Jesus. Even Richard Carrier. Oh, yeah. Go ahead.
I was just saying, like, Virgil wrote the Aeneid for Caesar. There are statues of Caesar during his lifetime, and yet they say he's just as well documented as Jesus. No, of course not.
Yeah, my favorite example with Caesar is the issue of in what language did Caesar and Cleopatra make love, if they did at all? And so there's still a bunch of things. Did he have an illegitimate kid by her, cesarean? There seems to be indication that it is, but of course we can't do DNA analysis. We can't do mitochondrial studies. So sorry about that. But we do have historical records. And so it doesn't mean it's a free-for-all. It looks like the only language they had in common was Greek. Because although Cleopatra spoke like about 7 languages, she could actually speak Egyptian, which was the first of the Ptolemies to do that. She was smart as a whip. But apparently Daddy, because he was pissed off with the Romans, never taught her Latin. And Caesar apparently only knew Latin and Greek. So when they were making sweet nothings with one another, presumably they were speaking Latin or speaking Greek. But we can rule out absolutely they would not be speaking Mayan. They would not be speaking conversational Klingon. There's a whole bunch of languages that we can be absolutely certain that they were not speaking. And so it limits the thing down. Anyway, with regarding to biological evolution, we now have a lot of tools where you have, in effect, proxy time machines. One of the ones, of course, are fossils. In order for an object to be the way it is, in order for a bone to look the way it is, it's got to have homeobox genes, it's got to have regulators, there's a whole bunch of things that are in principle intelligible. And that's where we get our super duper secret weapon time machine, paleogenomics, because we can start ferreting back more and more and more, reconstructing the steps in ancient evolution and testing them out in exactly the way you would if you had a dinosaur in the lab that you could look at today. We have to be harder at it, but still, it's something we can actually do.
Yeah, with like, there's so much research going into what was the Urbilaterian, what was the Metazoan, or the Nephrozoan, or what have you, or what is the, because we share all these. I actually read a very interesting book. It was titled crap, I can't remember what it was. Restless Creatures. There we go. Restless Creatures. It's about the history of life on Earth, but the guy who wrote it, the evolutionary biologist, he says the reason for the biodiversity of life is the need for motion, which is very interesting, because he goes back, he starts with us, and he's detailing how we walk and run, all the different muscles and their the different points of connection, insertion and whatnot. And so then he goes back.
Sessile. I love the word sessile, which is opposite of mobile. And it's no coincidence that what you really find with the Cambrian explosion and all of this other thing where things really take off is the fact that organisms can move. And once you have organisms that can do that, for one thing, if something is trying to eat you, you can run away. Or for that matter, if you're wanting to eat something and you can trace after it. Oh, you're about ready to jump in?
I was going to say, how about if I try refreshing? Maybe that'll get rid of the static.
Oh, okay. Yeah, jump out and refresh, and I'll fill the dead air with my dulcet tones while we wait. I'm not familiar with that particular book. I'd have to look that up and find out who the author of it is. I may have some of the technical papers. There's the notion of mobility. There's now circumstantial evidence that at least a couple of the organisms in the Ediacara biota were mobile. Not all of them were sessile organisms. And we do know, as we move closer and closer to the actual Cambrian-Precambrian boundary, that you're seeing more and more indications of bioturbation. You're finding things that are burrowing under the ground and all of that. So wormy things or other stuff of which you're not entirely sure. Back again.
How do I sound?
Oh, so far so good.
All right, cool.
Dulcet. Paul was just remarking dulcet. What a great adjective. Yeah. I love words. I love things that are unusual. Especially if it's a particular thing or has a certain ironic cast to it. And I don't think anyone would ever use dulcet to describe the way I talk. And therefore, I think it's even more fun that way. But yeah, we're in such an exciting period because the kinds of paleogenomic research that now is becoming increasingly common literally didn't exist 30 years ago, or even 20 years ago. They had to really discover the homeobox genes, and they had to have new techniques for being able to come down with a little tiny little scalpel and push the little gene apart, and send a little tiny submarine in, the equivalent of doing that, CRISPR and all these other things that they're able to tinker with on a much more tactical scale. That allows them to actually perform kind of retro-engineering exploration of stuff. And they started out with just proteins. You were looking at like lactase stuff that's occurring in the primate and milk things, all that kind of stuff that were relatively straightforward. But since then, they've been working more and more and higher level up in cis-regulatory stuff. Now, they'll eventually reach the stage where they can poke around more and more only with ancient organisms, but more advanced ones to figure out the origins of organ systems, of the immune system, of the flagellum, all of the stuff that are deemed to be irreducibly complex according to the poobahs at the Discovery Institute.
Yeah.
Ho, ho, ho.
There are very interesting papers on the evolution of flagellar motors, which I've seen a few of them, and they're very interesting.
I keep track of virtually every paper that crosses underneath my eyeballs on this subject. We're still in largely the data collection stage. It was only not that long ago that they found out that the stupid little cap on the end of the flagellum, what the structure of that was, that allows it to form the flagellum under relatively low concentration. In high concentration, flagellum automatically forms. It does it self-assembly. But the neat thing is what caused this cap to emerge, and what is it? And it would have to be homologous to something, unless of course it is designed. And the fact that the designer gang don't seem to be doing a hell of a lot of the work in this area, other than this. Scott Minnick is really the only one that I can think of offhand who is a design-friendly fellow. He's down at the University of Idaho and does, moderate-level stuff. Most of the heavy lifters in this area, frankly, are over in Japan. But the other thing was that the motor proteins, cleverly called Mote A and Mote B, which are the proteins that actually cause the thing to spin, and by which to this day, they're not entirely sure how it does that. There are a couple competing theories about how the electrostatic charges and all that are run around.
I mean, we're not even entirely sure of all the steps in cellular respiration, like how the parts get through the membrane.
But of course, if we don't know how it is, it must be designed because it looks complicated to them. But anyway, the motor proteins, they finally started to identify the homologous components that are not motor proteins that are in the flagellar, the non-flagellar system that are contributing to the development of this. So anybody who's going to draw the line in the sand and say, no, this is absolutely impossible, it cannot possibly have evolved, had better not be paying too much attention to the technical literature. And this is going to be an interesting matter as time progresses, is that the flagellum, or of course, already you're deeper into the things on the cellular membranes and a lot of the big five of his supposedly irreducibly complex systems. He laid down a gauntlet where he said in the original book, Darwin's Black Box, that if you could show that any one of those could develop by a step-by-step Darwinian process, well, so much for irreducible complexity. It just blows the whole thing out of the water. Now, I think when push comes to shove, he ain't ever going to do that. That if they find that area becomes, we can really account for that, you're going to hear a quiet goalpost moving as that's pushed off the field, and then he brings on the field another irreducibly complex thing to keep the thing going. But we'll find out what the circumstance is on that, and bring your popcorn as necessary.
Yeah. In that same vein, have you heard of ATP synthase, which is the spinning protein?
Yeah. Yeah, you got a lot of things. I guess it just wows some design advocates that stuff makes circular motions or spinny stuff.
I mean, I think it's pretty cool.
But yeah, it's amazing stuff. But the thing is that they immediately think it's designy, and they will always illustrations of it that make it look as machinish as possible because they want to have it look like the interior of a Wankel engine or something. And but even when you start looking at the fiddly bit details, you find out that things are a little bit more complicated than that. And of course, here's the advantage that a scientific method has. It doesn't care what ideology you have. What can you actually show? And it's always a dead giveaway which side is actually got the better end of the argument as to which side actually does the work and keeps on making progress, whereas the other side that's kind of carping from over in the corner somewhere is usually a sign that they're not the players in the game. So yeah, I keep track on all that irreducible complexity stuff. But the historical aspect is really pivotal because it was the design gang, Calvert and Company. I did a whole shtick on that in tip 1.7 at Troubles in Paradise on of the historical versus observational science gig that popped up in the basically in the 1990s, and then the young Earth creationists latched on to it, although aspects of their thinking were consistent with that. And it was a way of trying to draw a line in the sand that would say, hey, AJS is back. Hey, back, I am back. Yes, and we got Richard Brumley and Paul the Skeptic and a few others knocking around in there. Everybody out there, let everybody know that Jackson and I are jibber-jabbering back and forth on Darwin and historical science. Because this is really cutting to what it means to be the scientific method, how you deal with limited data sets. And because I do come at it from that historian's angle, where limited data set comes with the turf. I can't jump in the time machine and go look at Caesar. But are you ever going to argue that therefore we don't know anything at all? I once bumped into a nitwit racist at the place I worked, the door shop, that way I help make doors and stuff. And he, we were talking about, a couple of us were talking about slavery and Lincoln and all that, and the Civil War happened to be one of my big areas in college. And he had this accent, so I'm not insulting. He had this Southern accent. He says, "Those are just from books. You're just getting that stuff from books. How do you know any of that's true?" I'd hate to say
that that's not uncommon from my perspective.
Yeah. And I think we've got, although they don't necessarily sound as simplistic, but frankly, the climate change skeptics have the same attitude as that. They sound more fancy-schmancy, but what they're essentially doing is, well, you're just reading people that say that. And ultimately, however, you have data. And you've got historical information, you have physical objects, you have coins, you have written documents, and you can build up an argument that way. It's one of the reasons even on the Jesus issue is I did a little lecture. I think I got the link up at the website about it, where I lectured the atheist bunch over in Seattle earlier in the year. And yeah, and I was giving them a warning about don't use the Jesus is fictional argument, because it's a really slippery slope. You're really getting into an area where you got to have Richard Carrier have an arm wrestling match with Bart Ehrman, and you're on a slippery slope if you try to argue that, because there's an awful lot of historical personages that it's hard to document if you're being persnickety. So I'm saying don't go there. You can discuss the provenance of the history data. That's fine and dandy if you like, but you don't need to go there. I don't have to worry about whether Jesus existed. Do is to point out he didn't come back and set up the kingdom as he said he was gonna. I don't have to argue that when that didn't happen. So now we're on an observational turf that we wouldn't be with whether Jesus existed at all.
Well, what they do is they often, from what I've seen, they'll try to argue that that's not what the phrase means, even though it clearly it's like the Hebrew, because the Hebrew can mean several. They'll say it can mean several different things. So they'll say, like, instead of none of you, they'll say, like, none of your lineages, I think it is, will have survived.
Yeah, that's what, there's actually two sections. There's some of you here who shall not taste of death before the Son of Man comes in his kingdom. And then there's this generation shall not pass away before all these signs have taken place. And you'll find that the apocalyptic types and the messianic credentials type will tend to focus on the second one, but not the first, because it's harder to spin it. But we don't have to guess in the context. Boy, this is far from Darwin and historical thing, but it's actually the same methodology. It's that if you read the gospel accounts, the letters of Paul, and all of the people that were actually being killed as martyrs, St. Perpetua as an example, all the way down in the 2nd and 3rd centuries, every one of them was expecting the imminent second coming. This is not something that was an odd belief. Well, yeah, and it was actually St. Augustine who managed to make it a coming attraction by saying it's a metaphorical kingdom, by which time, they were centuries down the road. They got to come up with some explanation. Well, but nevertheless, it's a fun thing to play around with. Yeah. And it's once you learn the historical methodology, it's the same thing if you're talking about Nostradamus prophecies, if you're talking about whether Atlantis existed, if you're talking about ancient astronauts. I mean, it's a broad toolkit. So if you got it properly, you can deal with it fairly reasonably. But that same principle, it's no coincidence that the big tussle over Darwinism is occurring in the same time frame as the historical criticism, higher criticism movement was occurring in
Germany. The Germans were doing that, weren't they?
Yeah, they started out going after Homer, not Christ.
That's right.
And they were arguing there's no proof that Homer existed. I think you would tend to find, and the little, Wood, I can't think of his first name. He just did a wonderful series on China for PBS, and he did a spectacular thing on the Homeric epics, where he makes a good case for there being a real Homer, and that an awful lot of actual history with the Trojan War is reflected in the Homeric tales. And it's just a wonderful series. I had to buy the thing on DVD because he's just a fabulous historian, and plus a wonderfully entertaining guy to listen to. But anyway, as a historian, people do things, and I'm always very leery of ones that argue that ideas kind of float out there in an ether and they begin kind of sink into things. No, human beings do things and they say things. They can believe cockamamie things. I mean, we got a president who believes that, so we don't have to look very far on that. But I would tell people that I don't have to imagine Joseph Smith was a fictional character in order to say that the Book of Mormon is a pile of dingoes' kidneys. It's historically preposterous. So I don't need to fight the one battle to deal with the other. Well, back to Darwin and fossils.
Anyway,
damn it.
So my interest in this developed because of a video I did about 9 months ago, which was only a month after I started making videos, because I started making them in college because I just kind of thought, hey, why not? And now I'm doing it.
It's what people do.
And so, well, now I'm doing it for a different reason. Now I'm trying to educate people more than do the simple someone said this, I'm going to rebut this video or this article or what have you. So now it's more about just teaching these subjects. Like I just did a video on biogeography or how evolution works, whatever. So my interest in this came from reading, of course, creationist materials originally, and because they're the ones who use the terminology observational or operational versus historical science. It's not used. It has, as far as I've seen, it's never been used by a scientist. I've never heard it used in the lab anywhere. I've never heard it used historical science.
I mean, I think there is some the philosophers of science will go into some of the side bits, but that's about as deep as it goes, because functionally just look at about how do you deal with atoms when they talk about observational science? Have you ever touched an atom? Well, in a way, you touch the electron shells of atoms, but you can't just take up here is an atom, and I have it in my hand, and let us get out our little magnifying glass and let us look at the atom. No, it's inferential. And a lot of the things about quantum theory, it's mathematical, and that's why you have some of the people that go screaming bloody murder in the physics community over string theory and others, that it's not observationally enough. But you can find around to things where, say, quantum theory is as non-intuitive as you could get, although it has experimental evidence for it, and it works relentlessly well. But yet, do you really see quanta? Do you see superimposition states?
Right.
Can you touch and feel it? And here's my Schrodinger's cat box, where we got our thing. By the way, I've always wanted to say, excuse me, but isn't the cat an observer? I think the cat will know whether it's alive or dead before you actually open the lid, because it observes too. So anyway, this is just a quibble that I have with the cat experiment.
Yeah.
But so modern physics, modern science will bump into that observational versus historical thing. And meanwhile, when there's a quote I like to put in from Henry David Thoreau, for you youngins who may or may not be familiar with Thoreau.
Hey, I read The Night Thoreau Slept in Jail.
There you go. Well, there's part of your liberal education. Bravo. Anyway, he once said that some circumstances is conclusive like a trout in the milk. And that one does indeed sum it up, that we use circumstantial and historical observation all the time. Every detective mystery, all Sherlock Holmes stories are based upon that. Forensic CSI material. You weren't there to see the crime, but the blood spatters on the wall tell you how the crime was committed. The forensic details about what bugs are eating on the body tell you when it was, because the bugs are mutating at a certain time and gestating, and therefore you can tell how long ago it was, blah, blah, blah. So all of that is stepping back through time using your circumstantial time machine. And so taphonomy and biogeography, all of those things of animal distribution, what genes you have, what pseudogenes you have in your genetics, all of these things are just as much trout in the milk as if you actually had a Tiktaalik suddenly walk out of a time machine and start waddling over and gnawing on your elbow.
Well, they might, what was it Aaron Ross said? He's talked with people who say, like, if they got in a time machine with him and went back 65 million years ago, they would deny that what they're seeing is real, that it was like a trick of the devil or whatever.
Well, actually, I don't know. It'd be fun to find out.
Indeed,
if Phileas Fogg can ever loan me his time machine, we can actually go back and find out. We really don't know the circumstance, and that's. But it is possible to do thought experiments on the other end, because what too many people, when they're dealing with creationists, fail to do. Yes, you're supposed to explain what our position is and be able to defend it clearly, but you should be asking them what their position is. That's one of the reasons, if those who have been following me on Twitter should have noticed by now how often I will ask a flood geology advocate, oh, that's fun. Will you explain what the flood layer looks like where you live? Because there sure as hell ain't one here in Spokane. So please explain to me where this flood layer is. I would recommend that if anybody does a debate with a creationist in their own home turf, you would do research on the geology of the area so that you know the geology inside out, and ask them to defend where the flood layer is, where they are. $9 to a hole in a donut, they will have never thought that through within their own framework. And so that's an opportunity. The same thing as a similar issue that I've always wanted to try this out with a creationist or an intelligent design advocate. Frankly, it would be the same issue. And that is, okay, we're going to talk about the Cambrian explosion. Let's talk about the Cambrian explosion. So let's imagine we go back onto a beach in the Cambrian and say, oh, how many in the audience know what the hell we're talking about? And I bet an awful lot of people won't really know. That gives you the in. And you go, well, imagine we're standing on a beach in the Cambrian, and there's a river coming down from a mountain, and there's maybe a volcano spoop-booping out in the middle of the bay. And, well, you tell me, and you turn to your opponent and say, explain to the audience what we're seeing in the way of life. Hand it over to them to show off. Now, you may have miscalculated, and maybe that person knows Cambrian fauna inside out and will be able to really show up, in which case you just move on and discuss the Cambrian fauna. But what if they have built their entire argument on reading secondary literature? From reading the secondary literature, that they don't really explain that much. I bumped into a creationist who was listening to a lecture just before Casey Luskin in 2013. And I read Steve Meyer's book on Darwin, Darwin's Doubt in the Cambrian, and I was asking him to describe the life in the Cambrian. And he couldn't do it because there weren't really any good descriptions of what the life was in the sources he had read. So if it's what I call the map of time. And everybody should have a map of time. I hope you are developing a map of time in your own head so that even if you don't know every little fiddly bit moment in time, you have a general idea that I am pretty sure that if I went back to 1860, I would have a better chance of bumping into Abraham Lincoln than I would Eleanor of Aquitaine, because I've got kind of a good sense of the time frame. But if people are not really building an argument so that they don't really have a map of time, they have a desire, they have a bumper sticker of a map of time in their heads, where they've got
the Cambrian
appeared all at once. Yeah, the phyla appeared all at once. Well, what the hell's a phyla? What do you mean by it? In fact, I asked one creationist, and I couldn't get a damned answer out of him. In fact, I think I asked Douglas Axe this question just a little while ago from the design movement, and I never got an answer either. And I said, I would ask, do you believe anything alive today is physically descended from anything that was alive in the Cambrian? And suddenly, boop, we get silence. Because that would mean they'd have to think through what they think happened. They would have to implicitly have a sense of what speciation means. They would have to have, if they're creationists, they would have to have a clearer sense of what a kind is. They would have to know the range of existing organisms and the range of what they think was created and when and what. Well, none of them have ever thought about that. So they can't assemble a map of time because they don't have the little Lego blocks in their own apologetic literature to do that. So isn't it a good idea for us to maybe point that out by asking?
Yes, definitely. It's my central problem though with, well, okay, well, for one thing, on that same vein, I've never met any creationist who can aptly describe anything about the Cambrian. Just they can't, they don't know what it is. They barely know when it happened. They can say, oh, it happened 500 million years ago, which is
problem number 3, Pip, the map of time problem.
Yeah, it's like, I mean, they can barely tell us when it happened. They really can't tell us anything about the life forms or anything like that. But my main issue with the concept of historical science is that it's not precise. How far do we have to go back in time before something becomes historical? Is it a minute? Is it an hour or a year, a millennium?
Yeah, you know, it's like here again, the historian, all of this is stuff I'm already aware of. The French Revolution, they decided the modern age begins in 1792 or 1789. That's the dividing line. Boop, everything before that is just ancient history, you know, so everybody redefines their terminology. And then imagine the problem that most people get into when they have to deal with million years means, or 100 million years, or 1 billion years. You know, they'll bandy things about. There was I'm not sure what his position was, but anyway, he was saying that here, human beings appeared in just 2 million years. That's quite a long time. That brings us all the way back to Homo erectus. And in fact, we have a longer roundup before that. And so if you know, for one thing, if you develop a clear map of time in your own head that's grounded in actual information as much as possible. So if you want to talk about human evolution, you should be familiar enough with the players that if you see a chart popping up on the screen, you can at least get a ballpark recollection of what the hell you're looking at. And if you can't do that, if you can't say tell an Australopithecine from a Neanderthal kind of at quick glance, then excuse me, you're out of your depth and you better kind of go away because
I can't move in.
Yeah, and I think that's another reason where if you suspect that somebody knows way less than they think they do, then that's a relevant bit. Stop me if you've heard this one. But if I haven't told this one, then I want to. And it's the moment that I was doing this with Steve Meyer at his lecture on the Cambrian explosion at Whitworth College. And this is years ago. And it's before he moved to the Discovery Institute. And he was his professor, and he was doing his little course on the wonderful magic of the intelligent design notions. And the problem is it was open to the public. He had remembered me vaguely before because I bumped into him earlier, and I was sitting down in the front. My sister came along, and she was taking notes on a big yellow pad in the back of the room. And I specifically, he went through the usual boilerplate. It's the same lecture that you get over and over again about where's the origin of information, blah, 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 you know, and you can pad it out in book length, but it's the same shtick. And I was then asking him, well, about fossil preservation and what you would be looking for before the big explosion part. Don't we have a limitation about that? And specifically, how many Timoshan Lagerstätten are there? Mm-hmm. And boy, he stopped dead in his tracks because he didn't know what the hell I just asked him. Lagerstätten is a perfect legitimate term. Tomotion is the intermediate phase. It's after the Manichaean phase, and then the big Cambrian part that occurs a bit later on. It's the period known from the small shelly fauna, which he had to have known about because he was showing them off at the Whitworth College years earlier.
In theory, he should have known, yeah.
You see, and Lagerstätten in particular, I dinged him on that term for years. I did the same thing with Casey Luskin. So he just stood there. And for one thing, he couldn't figure out how to reply to it initially, because to do so, he couldn't blunder away and say, what the hell did you just ask me? Because that would sound like he was not knowledgeable in front of his students.
On the one subject he's talking about.
What seemed to me a ridiculously long time, long enough for my sister to notice there was suddenly a silence in the room, and she was looking up from her notes at the back end of the room, she told me later. And finally, as the little gears were working around in his head, he finally said, and your point is? Whereupon I explained the point. Now, the issue is that we know from the Tomotion phase of the Cambrian that there were these little small shelly fauna, which on all the evidence that you have are probably very primitive mollusks, really tiny ones, or little itty-bitty little things. And so that molluscum phylum predates the big Cambrian explosion. Then you have to ask another question: why shells? Why are these proliferation? There's a whole ecosystem shift that was shifting between the Manichaean phase, when there's almost nothing alive, or at least nothing you can see. Why? Because there are no Lagerstätten deposits. Those Lagerstätten, the preserved small soft parts, are really rare. And there's practically none anywhere in the Precambrian. There's one, the Duchanteau deposit, that's about 600 million years ago-ish, that preserves embryos. But problem, and I noticed that when Jonathan Wells mentioned it, he never mentioned this little factoid, is that phosphatization can only preserve things up to 0.5 millimeter. Can't tell what these little embryos are evolving into or developing into, because that would make them too big to phosphatize.
Okay.
And so that's part of the difficulty. So you have these millions, literally 10, 20 million years worth of stuff that's happening after the Ediacara ecosystem collapses, and before you get to the big Cambrian fauna in the big Lagerstätten that we have, that are all equatorial deposits, which suggest ocean chemistry. What the hell was crawling around in the Tomotion phase that those little Tomotion small shelly fauna? There's a whole missing ecosystem that we literally can't see, because they're really small, soft-bodied critters that don't leave fossilizable hard parts, and there are no Lagerstätten around. That's why that's a meaningful question. And that's why I've never been shy in discussing the Cambrian explosion, because I know the fan. I noticed Paul, I think back there, mentioned the chordates and all of that earlier in the feed. The fun thing about it.
That was the later early Cambrian.
Yeah. What if you remove the 3 Lagerstätten, which are Shengjiang in China, and the Sirius Passage in Greenland, and the Burgess Shale up in Canada. You remove those 3, third of the chordates in the Cambrian virtually disappears. You've got a really super duper primitive jawless fish that was found in the later Cambrian, and it's not in a Lagerstätten deposit, and that's it. That you've just vaporized an entire phylum if you go on that. But what are you finding when you put the Lagerstätten back in? I asked Casey Luskin at that. It was a productive meeting, even though he was skating around on thin ice all the time. But I asked him from the audience, were the chordates that evolutionists were predicting for the early Cambrian exactly what they found? And he didn't seem to have bothered to study that, because when you're reading the material from the 60s, 70s, and 80s, they were predicting that extremely primitive chordates were going to resemble lamprey larvae. And that's exactly what they did.
Well, Darwin
Haikuella,
well, Darwin was even mentioning like lamprey-like larvae for tunicates back in
the tunicates. That's really fun.
Back in the late 1800s.
Yeah, look at Jonathan Wells's Icons of Evolution book. I get a rib tickle out of this. And for the same reason, check out Darwin's Doubt. Wells and Meyer include the tunicates in with the chordates. But this is something that only an evolutionist should be able to say with a straight face, because, you know, they're just at the boundary layer. And of course, for those of you who aren't familiar with sea squirts, they're a wonderful little thing. In their adult form, they're this little pulsating bag that looks like a jellyfishy kind of thing that sits on the seafloor. It's a sessile organism. Remember, we're back to our little world, the sessile. But they have a free-living larva. And it resembles a lamprey-like larva. It resembles and it's very primitive and basal, and that's one of the reasons why they're regarding the tunicates as fitting in there. And I love the fact that when they finally land, I can't remember that the paleontologist, the scientist, she's a primatologist, but she had a snarky line about, yes, and the tunicate, when it finally turns into its adult form, it devours its own brain like an associate professor getting tenure.
Was that Goodall?
I love that. I can't remember. She wrote it. She's done a lot of stuff on language, primate language research, and I can't think of her name off the hand. It's not Hardy or Hurry, but something like that.
I saw that line.
I love the line. It's a hilarious line. I had to quote that because you know how I am printing magnolias. I mean, if there are some lines where they write it better than you can, you gotta quote them because, you know, you can't improve on that. But anyway, what would a even earlier proto-chordate look like? Just like what would a proto-trilobite look like? What would a proto-arthropod look like? They're going to be really tiny. The chordates that we see in the Cambrian are only about 1 inch long, and they're all soft-bodied, that if you don't have a Lagerstätten deposit, they're invisible. Unless they're bioperturbing a lot, the place could be crawling with evolutionary ancestors, but they're going to be very small and difficult to find. Now, if evolutionist is not allowed to bring all their field onto the stream, on a data stream, then don't we have to play this consistently? How does the intelligent designer know how many phyla there were in the Cambrian? Only half of them have a fossil record at all. So and so a lot of them can't be traced back anywhere, let alone all the way back to the Cambrian. How do we know that Chinorhynx or some of these other ones that have a really that just popped up? There was one phylum that was only discovered in the 1950s. Can we not offer as a potential hypothesis that the designer literally created that phylum like the day before it was first scooped up in the ocean? I don't think that's likely because I accept more data than just that. But if we're proceeding from the hair-splitting intelligent design perspective, on what basis could they plant it back into the Cambrian without using an evolutionary assumption? I'd love to see them do it.
And then they accuse us of using their assumption to do science.
Yeah, that's why I like to ask them how many phyla there are and how many of them could be traced back to the Cambrian. Because every one of them, the ones that Meyer and that know enough about the data stream to be very wary about traipsing onto that turf. But nonetheless, it's dangerous turf. Because I can say, listen, on evolutionary grounds, everybody is virtually certain that with I think the bryozoans are the one quibble, that all of the animal phyla existed in the Cambrian. But it's on evolutionary
I do believe
grounds.
bryozoans are Cambrian, as far as I've read.
They may have found some new ones since. In fact, I know if I ever get around to doing the Cambrian burp thing for TIP, it will be, I'll have to do a complete full court press reanalysis because there's been some new fossil material that's popped up along that. But still, there's an awful lot of phyla, especially little wiggly ones that are so small you need a microscope to see them. These things, the odds are against ever finding that out, but they've got genes. That we can observe what their genes are, and we can see how they connect up. Some of them are difficult to figure out some of the finer point relationships because we're 500 million years or more from the time that they split off from some other putative ancestor. But paleogenomics never rests, and the fossil gene never rests, and we know a hell of a lot more about the game now than we did when you were born.
Yeah, indeed. Also, side note, I will be referencing your work on the fossil genie in my next video. So,
goody! Popularize the term. Yeah, by all means use it because I wanted something that would be a handy thing to remember because it's the idea that there's this genie sitting around there who's saying, you know, boy, those poor little evolutionists, won't they really be happy if I just create this little animal form and put them in right deposit that's going to be exactly right? When you see the smile on Paul Sereno's face when he sees this, it's just going to be wonderful. So the genie just goes around doing this all the time. And for some reason, he has a real antipathy for doing things that make anti-evolutionists happy. A poor old Kirk Cameron doesn't realize it. But the crocoduck would really be a problem for evolution if it existed.
What would be?
But it would be a crocoduck. Yes. Would be a problem for creation. Explain why theoretically God could make a crocoduck. I guess it would not make any sense at all from an evolutionary perspective, and it's not what an intermediate between a bird and a reptile ought to look like. It's just a weird Photoshop chimera. But can't God make a crocoduck? And if so, if God really wanted to stick it, or the fossil genie wanted to stick it to evolution, a crocoduck would be a really cute thing because it would be taxonomically difficult to organize. But the failure to have a crocoduck, same way as, evolution can tell you a lot of stuff about stuff. King Kong is impossible. Giant dragons a la the Game of Thrones are releasing. Yeah, Pegasus. Way too big. There's no vertebrate that can do a standing start takeoff. Plus, a lot of the dragons and the flying horses are hexapodal vertebrates, which for some reason there ain't any. And that's an interesting developmental question. When you get into higher level notions, why is it we're tetrapods? Could there ever be a hexapodal vertebrate? And it's an interesting question. We know that there's a lot of interconnective constraints. Like I noted some material on the fact that once you have animals that run on 4 feet, there are constraints in terms of the ability to handle lungs and viscera and a lot of other stuff that really work against adding cervical vertebrae and other vertebrae. And so you've got dynamic constraints that come into play, which tend to limit things. In other areas, you're looking at the experiment that was done with the dinosaurs, they don't seem to have some of the same constraints. And therefore, you can infer things about their genetics and their biology and their interconnections in ways that where you're functionally doing a paleogenomic detective job on 2 widely disparate phyla. It's always struck me important that independently, the diapsids and the synapsids developed on their own separately 2 warm-blooded cohorts, birds and mammals. The birds developed after the mammals did, but nevertheless, that raising thermostat thing took place independently in lineages that are really quite separately developed. In some of the cases, some of the systems that are involved in language processing have occurred convergently in birds and human beings. We have a very different construction mode going on it. In the same way, yeah. But yet, in other words, that there are ideas that there are certain things in the way the game can work out. And theoretically, then, super duper evolutionary science of the 80th century, especially if they find life anywhere else or life anywhere else contacts us, we'll be able to tell a great deal more about the contingencies of history. I mentioned before my suspicion that multicellularity is inevitable in a biological system. It takes billions of years to get to it, but if you don't have a problem with it, there will be various forms of multicellularity that will develop.
Yeah, definitely. But, there are definitely lots of experiments with predation, like Ochromonus, I think it is one, where it goes after, I think Ochromonus goes after like an algae, and the algae clumps together, if I remember correctly. And so they form these little groups of like 8 or something like that.
Yeah, so. Volvox, that's one of the cuties in the biology thing. And it's not that these bacteria are on their way to become Dwayne Gish or Kent Hovind. It's that there's a lot of different ways that cell adhesion systems work. And now that's one of the reasons why you, again, have to remember the date of the material, that a lot of the bits and pieces of these things weren't even known ago, and the genes governing them weren't known until relatively recently. So a lot of these areas, they're only now starting to come out with a fresh law, wind, and the Evo Devo department is just as exciting as all get out, because now they have more tools and more of the toolkit to play around with to see how things are developing at the genetic level. More ability to peel away the things and look at the variations, because it's through variation that you can figure out how the evolutionary thing looks. And one thing you clearly see, fossils or the genetics, any of these levels, is if you take any individual slice of time, it sure looks like just natural branching speciation's going on. That you don't find really novel things suddenly poofing out of the middle of nowhere, unless it's just an accident of preservation. Like, and that's why the reptile-mammal transition is the killer app here, because you've got such a plethora of material, and it's so slow and gradual that there is literally no spot where you can say, well, mammals are appearing poof out of the middle of nowhere with no antecedents. There's always something a little less mammal-y going back farther and farther and farther and farther and farther. So the only way they can avoid the logic of it is to never look at the data. We had a reference here. Oh, you were mentioning Spinosaurus. That is one of my favorite. That's one of the big feedback.
Yeah, I was talking about it with AJS, which he mentioned. They were talking about we were talking about the crocoduck, and they were talking about it in the chat. And I said one of them mentioned an article, because I saw an article a while back that was like saying Spinosauropteryx is like the crocoduck, and I asked him if that's what he was referring to, but he said it was Spinosaurus, and so I was like, Spinosaurus is really weird, because it's no longer thought to be bipedal. Now it's a quadruped. That's weird.
That is new material on that. I know they've got the big spine tail fin back. I think they are from Africa.
Well, now the Spinosaurus. It's not even. It's like, not only is it like quadrupedal now, but it's also, you've seen like Jurassic Park.
Because that would be very interesting if so.
Yeah,
quadrupedal.
Also the spine. You know how the spine, like on Spinosaurus in the movies, is like this semicircle? Well, it turns out it's got a dip in it. It's got a weird dip, like right in the middle. It's very strange. It just keeps getting weirder.
They're quite large animals. They're practically Tyrannosaurus size. They're substantially. The oldest one, I think, was known from an extremely fragmentary skeleton. So they've only just found some bit more. Paul Serino, I think, has done an awful lot of work on that area, and I got a model of him in my dinosaur collection. The interesting question is why finbacks show up at all on organisms, and they don't seem that they're be within a lineage, but the question is they're not popping up like a dime a dozen. And so you have like Dimetrodon and that bunch back in the mammal line. You've got your assorted finbacks that are popping up. Ouranosaurus seems to have very tall spines, and it's over in the hadrosaur group. So that it's very sporadicness thing, because it looks more like something that's a convergence feature that relates to a suite of behavioral and ecological characteristics that we don't know enough about to be able to predict what the hell's going on. So it's an interesting little question. It puts a little question mark, because that's what the scientists love to know the answer to, because why would you be studying the stuff you already know the answer to? That's kind of boring, isn't it?
Yeah, I agree. I think I love paleontology is great. I love that subject. And it's just, but for Spinosaurus, it kind of seemed like that was something we should have figured out by now. And then a few years ago, they were like, well, maybe we don't. Maybe instead of it being the huge towering biped that it was in Jurassic Park, for instance, maybe now it's more of a quadrupedal.
Well, it was certainly a predator. The interesting bit, remember, we tend to think about theropods as pure bipeds. But we do know that there are some weird exceptions. There are some herbivorous theropods that came along down the line. I think the therizinosaurs developed.
The therizinosaurs, some oviraptorosaurs, and a few others.
I think it's fair to say that the point that was made back there, that the basal group for dinosaurs are functionally small bipeds. If you look at your little itty bitty
small, probably carnivorous bipeds.
That's the format. Herrerasaurs and all the rest, that's the basic thing. And so you would get this kind of adaptive arms race of standing up on front feet and allowing your little arms to be accessible. But routinely, some of them go back into a different lineup there. So quadrupedality develops. You have ones that are multiple. They can balance on their hind legs like hadrosaurs, and yet they're still quadrupedal, but nonetheless they're apparently able. They have defensive claws on their front paws that are probably suggesting that they could rear at times. And I always put up the rule: if you got into the time machine and went back in time to look at any of these mysteries, when you stepped out of the machine and you did your little David Attenborough routine, oh, there, over there is a Tyrannosaurus. Oh, it's so fascinating. You go, oh, of course, duh. Oh, so stupid of us not to realize that. Now, when we see it in its ecological context and how it behaves with the plants and the animals and blah, 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 and what it looks like in the morning, oh, of course, duh. Yeah. Oh, dumb.
Yeah, and that'd be really cool.
But we have to kind of infer all of that 1,800 miles removed, because all you got are the pieces of some bones and little bit of taphonomy on its context and all that. So it's tough to do. Plus, you don't have any dinosaurs to look at. You can't look at their genes. You can't look at the dynamics of it. So you can make inferences.
Yeah, that's why they talk about stuff like a biological bracketing, where it's like, oh, birds and crocodiles have colored vision, so it's likely that dinosaurs also had colored vision.
Yeah, and sometimes it's a wise thing, and sometimes it's not. Because the more we look at the little fiddly bit details, we discover that the enormous amount of variation. And this is why Darwin, of all people on Earth, smiling like the Cheshire Cat if he could be alive today, because he'd be saying, told ya there was even more variation. That's what evolution uses. Ha, ha, ha. And that would be exactly the thing. There's the ones that think that Darwin would be blown away by all the stuff. No, he would be delighted. He'd probably be thrilled to know that we finally figured out how inheritance worked. And he said, well, so much for gemmules. I knew that was a stupid idea before I even died. But to know that it was a little teeny molecule that actually was known, but no one had made the connection on it. And if you look at somebody like Linus Pauling, who was thinking that the inheritance mechanism had to be a protein, that this nucleic acid, that this little weird little stuff that gets wound up, could actually be the mechanism of inheritance. It was not immediately obvious to everybody. And then it was quite a few years. It was another 10 years or more after they actually found the DNA helix to figure out the nucleotides and the triplexes and kind of figured out all the stuff. That now we just look at it, well, of course, duh, we know all about that now. But it wasn't immediately obvious at the time.
Conceit of hindsight.
That's another one example that I like to give is before somebody says, well, they should have figured out the origin of life by now. How long have we been going at this, and how many people are involved in this? And it's kind of a hard thing.
Well,
so let me ask them, how is lightning in the thundercloud?
We talk about it. We've had guys like O'Para and others making like hypotheses since the 20s, but the real experiments have been going on since the past like 50 or so years.
Since you didn't know how DNA worked before 1950, whatever,
with Watson
everybody speculating on it beforehand was speculating out of thin air. But the thing is that some problems are really difficult, and the thundercloud problem is a perfectly fine one. That to this day, nobody knows how lightning is formed in a thundercloud. It exceeds the ability of supercomputers to model the number of little dust particles and water vapor in there, and they can't quite figure out how it works. Maybe someday some super genius will do it. Another example that I use from pure mathematics is Fermat's last theorem. Familiar with that?
Well, that one was solved.
Well, yes, but the fun part is how it was solved. Fermat had written down a margin in his little book just before he died saying, "Ooh, I'm sure this is true. I have a wonderful, purely beautiful proof that it's a bit too big to fit in the margins." And he never wrote it down. And so for the next 400 or 500 years, mathematicians were banging themselves against the wall. The greatest minds in mathematics, Gödel, everybody else was, Bertrand Russell, everybody tried their hand at it. Nobody could figure out. Till this little, a minor league mathematician figures it out. But the problem is, he made use of mathematics that wasn't known in Fermat's day. So the suspicion is that Fermat couldn't have had a proof because he didn't have the mathematical tools to be able to pull it off. But that's pure mathematics. Theoretically, all you need is a bright mind and a pencil and a piece of paper. You could work out Fermat's last theorem proof too. And that's way simpler than trying to work out something with the origin of life where you don't know what it is you're trying to origin. What does it mean to be a metabolism? What does it mean to be replication? You know what it does in the finished model, but we are not certain that that's the initial living system. We're only looking at it way down the road because we're looking at it with RNA and DNA and a symbiotic relationship, and we got ribosomes and all this other kind of stuff and extra proteins. Now, the anti-evolutionist is always running off on what we don't know on here. And maybe they're right. Maybe it'll turn out in the being dim of time that we will know absolutely certainly that life cannot originate naturally. It still won't make the reptile-mammal transition go away.
Yes, whatever theory they come up with would have to encompass absolutely all the data that we already have accrued. It can't replace any of it. It has to account for everything we've already found, which is something I guess a lot of people, they don't understand when they're talking about science. They think like, oh, a theory just replaced all the old one. It's like, no, the facts didn't go away. They had to be incorporated into the new one.
Newton and Einstein are the perfect example here. When Einstein said space is curved and E equal mc squared and all that kind of stuff, it didn't mean that hammers fell differently now. It didn't mean the moon suddenly slipped out of its orbit. No, everything still happened the same, but it had the advantage that not only could Einstein explain why the perihelion of Mercury precessed, based on relativity theory, down to the gnat's eyelash, but they could also explain why Newton works so well, because when you looked at relatively slow-moving objects moving in non-relativistic context, like little satellite going out to Jupiter, that collapse down to where nobody at NASA is going to waste their time trying to calculate the little trajectory of the craft using Einstein. It's just way too complex math. Use Newton. It still works just fine because you're not dealing with relativistic effects. So you're changing the fundamental assumptions of things. Space is not absolute. Time is relative. All of that now alters the context, but it still doesn't mean that within the tiny frames of things that are only like 1 billion miles apart, or things that are over tiny time frames like 1 million years, that everything is running just perfectly normal for Newton. Hasn't changed that at all.
Exactly. Yeah. Well, to get all the way back to the topic of our video, historical science. Yeah. I wanted to
You're going to be doing a video on this, right?
I will be doing a video.
Your own lecture thing?
Yeah, I'm working on this script for. It's actually turning out to be a fair bit longer than the normal videos I make, which are usually between like 5, 6, maybe 7 minutes. And so
it's a big subject. It may seem so trivial. It's just historical science, but it actually cuts to the core of what it means to do science.
Yeah, and what's really funny is that this is going to be part 2, an unintentional part 2, I should say. I thought I would have covered this. I made a video about it, the observational versus historical science video. I made a video about it 9 months ago, which is what I said earlier. But when I made the video, I made some maybe ambiguous statements. For example, I said scientists don't use it. Well, and the quote that I've seen the creationists have thrown at me is the quote by Ernst Mayr in the 2009 article.
Yeah, you sent me the link to that, all that. Yeah. That's it's the same reason that some people will insist, no, macroevolution is just made up by creationists. No, the term actually pops up in the regular scientific literature.
That's the thing. Well, the problem was he was, well, interestingly, the one place where he says Darwin introduced historicity to science, which is wrong. He didn't. Lyell did, and the other geologists, like at least 29 years before Darwin wrote Origin of Species. But even aside from that, the problem is the difference between. Well, for one thing, I've still never seen any scientist use it, and when I have looked through the data set for where I can find historical science in a paper, it's almost always, like you said earlier, it's almost always philosophers of science. It's
Yeah,
not.
when you get into Polyani land and things like that, but in terms of everyday stuff, everything that you do in the sciences is based on a direct observation.
Mm-hmm.
And then you're drawing inferences from it because you don't actually see atoms. You don't see mountain range, although now we can kind of measure mountain ranges moving, but nevertheless, you couldn't really do that before. So there's always been a complex interplay. And back to astronomy, the ultimate example, the one thing you can't do in astronomy is see Andromeda as it is now. You can never observe Andromeda as it is now. You can only see what it was doing 2 million years ago. And so you're seeing this layer cake of time travel around in there, which allows you to infer lots of things. It's like seeing, how could you see a star form? Well, if you have a really long lifespan and sit down and watch the nebula coalesce over a period of 100 million years, but make sure to bring an awful lot of carrots with you for snacks.
Make sure you're Noah or one of his descendants.
Yes, indeed.
And you can probably see some observable change, but as for the rest of us, not so much. But what's funny is this video is actually going to be quite a bit longer than the original video that I made on this topic, because not only do I clarify this, I also talk about the quote. I explain why the quote is wrong to an extent. Ernst Mayr, great guy, smart guy, but he's a little bit off in a few things that he says in this article. But at the same time, I have to say this because it's so funny. It's one of those adorable little inconveniences that the anti-evolutionists have to skip to push their narrative. In the article, he says something to the effect of, no learned person denies the theory of evolution. It's a plain and simple fact. He says that in the article, which is funny because all the anti-evolutionists are like, aha, see, scientists are using historical science. It's like, guys, did you skip that part before you got there? Because you must have missed something.
Yeah, it's why I'm always, I simultaneously don't want to get hung up on definitions, and at the same time, you always want to be aware of definitions.
Yes.
So when people who use terminology in a squishy way or with a baggage attached to it, and that's the reason why they're using the particular terminology that they are. So I always like to kind of step around. There's a general principle that I came up with in the tip. I didn't invent it, but I try to articulate it and embody it. These need to be grounded in specifics, and all specific examples need to be relatable to some sort of generality. Otherwise, why are you bringing them up?
Right.
And you'll find that people that play fast and loose with things will be bringing up some little specific gotcha thing. How do you explain so-and-so? Well, so what about that? Or a generic principle that they are dumping on you. Well, can you give me an example? And if you remember that you need to answer the same questions too, if anybody challenges you on it, although they may not think about it, that's an important way of clarifying what the hell people think about stuff. When they talk about the origin of life, $9 to a hole in a donut, they don't know what they mean by what the life is. Do they think it's just the stuff that's now? But the problem is historical science can tell us that life didn't start out doing now what it has now. It started out with just bacteria.
Well, they don't even seem to understand that life is a description. It's not a thing. It's not an object. You can't hold life in your hand. You hold an object that displays the characteristics of life. Rocks aren't,
and it's indeed
living.
It's difficult to explain the primary core terminology. I've never really seen
I made a video for that.
A rigorous explanation for metabolism.
Oh, yeah, no, I didn't explain that.
But yet, is there like a law of metabolism? Is there a formula that says that's metabolic? No, because it's all ultimately chemistry. That everything we describe as metabolism is an exchange of electron shells in largely organic elements. And yet, if you look at the pieces of the thing, actually alive, but the coalescence is. So now the thing that this is a careful area to tread into, because your intelligent design gang in particular will say, well, that's because there is information that is added into this, and information only comes from intelligence. And so there you then move into another level to where they've got their Achilles heel as well. Dembski it's no coincidence that Bill Dembski has fundamentally packed up his kit and moved on to theology, because the one thing he never did in his career was to take any of his little formulas on complex specified complexity and ever apply them to genetics. And I don't think he can, in principle. I don't even think Axe or Gauger or any of those other people in the intelligent design movement that are kind of prattling on, Sanford and all the rest over in creation science land, that if you were to give somebody a string of A, T, C's, and G's, would anybody, evolutionist or not, be able to just look at that code and say that that's a viable organism or not? No, you can't tell that. And the same thing, if you were to give you two genetic codes, of which there's variations between the two, would an intelligent design person be able to tell which one was the original design system, if any, or if one of them is a natural evolved element from it, and on what basis? I'd like to see him try. And the stick kind of difficult from that. And so you can then, once you recognize that gap, then you can start homing down to some specifics that you can sink your teeth into. And the one that I've been trying to knock around at the moment, and it's interesting to hear what answers I don't get, is, are all the ALUs in our genome designed? And I couldn't get a straight answer out of Ann Gauger on it. I couldn't get an answer out of Douglas Axe. It's suddenly what are you looking at the Tortugan deer in the headlight moment? Because there's a hell of a lot of ALUs. Transposon, we know they self-replicate. We know that unless you got a start codon in the beginning, which it doesn't carry,
good old methionine,
it's going to be red. So are all of them designed? If all of them are designed, then the ones that cause diseases were designed because a bunch of them cause diseases. So now we've got a very sadistic designer of all of these little ALUs. And so it's no coincidence that everybody that tiptoes into this area. They will bring them up peripherally as though there's just the ALU. One that you've read Darwin's Black Box?
No, I've read The Real Darwin.
Well, if you want to attack intelligent design, it's always wise to have read this stuff. And Behe's stuff is fun and games. Anyway, one of his irreducibly complex 5 is the immune system. And in that are the major histocompatibility molecules, MHCs, which, by the way, figure in vertebrate sex, because how people fall in love is partly contingent upon the compatibility level of their MHC molecules. And if they don't match up properly, they can predict whether or not you're not going to like this person no matter what they look like, because you're just not syncing up. Anyway, that's part of our little vertebrate each other out through our MHC molecules. But anyway, there's not, Behe acts like there's like one MHC molecule in this irreducibly complex system. But in fact, there's huge families of them that have shown natural evolution over time and all the rest. So that would be an example of, it literally doesn't occur to him to do a map of time question within his own framework. Okay? Here's all these MHC molecules, the data we need to account for. And here, using my fabulous intelligent design theory, I'm able to work out which ones are the examples of original designed MHC molecules and which ones are just microevolutionary variations. I'd love to see him try that little one, but he doesn't get, he's not a researcher in the field. Tom Cavalier-Smith, who is an immune system researcher, lit into him with a vengeance when he reviewed the book back in the 1990s. And it is most revealing that Tom Cavalier-Smith is one critic that Behe has never written a reply to.
Yeah, I mean,
always tough to know. Well,
you were talking about ALUs. As far as I've ever seen, I've never gotten a straight answer from what genetic information is ever. Because I ask them, and I say, well, they say, information only comes from designers, like you said. But you ask them, what is the information in DNA specifically? And they say, and this is what Kent Hovind said the same thing. He said, the DNA is full of information. I said, okay, well, what is information?
Yeah, well, it does ATCG, CTTT, ATT, CTCTC, ATT, CTCTT, CCTT, TCT have more or less information than ACT, TTC, CTT. And you can just rattle off just complete random permutations of these things. How do you tell what the information is on there? This is the problem of the code breaker's dilemma.
That is part of the problem, but also the problem is that they think protein coding genes are the only thing in DNA. They don't know about retrotransposons or
yes,
endogenous retroviruses or pseudogenes or all this other stuff that's on there that's not doing the same. That's not doing that.
The way I'll use.
Yeah, they're thinking, oh, DNA is just these little bits of nucleotides that are doing work. Well, what about endogenous retroviruses? They're not doing anything.
It's fundamentally the same flaw that Paley's watchmaker analogy got into. And Paley himself got to the finish line, but he couldn't quite figure it out. Because when you pick up a watch on the heath, how complicated the watch is, and life is so much more complicated than any watch. The problem is, in living watches, the watch you pick up on the heath is not the designed object. It can't be the designed object because these watches replicate. So what you are seeing is a supposed descendant of a designed object. Well, when exactly did the design come in? And all anti-evolutionists, everybody in the design camp, up to and including Michael Behe, just doesn't think about that. You can't pin them down as to what they think the original design systems were, how many of them there are. They don't think historically. It is no coincidence that young Earth creationists and intelligent designers both never work out a map of time conception, even though they have very different conceptions of how many zeros they're in on it. Steve Meyer isn't thinking the Earth is 6,000 years old. He thinks it's billions of years old. But if you look at their writings, you think about this moment in time when there would be the very first fill in the blank, and then this happened, and then this must have happened, and then this must have happened based on the following information. That argument never occurs. And that's why Steve Meyer, and I can't remember who the fourth author was, but the other ones were Marcus Ross and Paul Nelson, wrote a paper in like 2004 or 6, somewhere around in there, on the Cambrian explosion. If I ever bump into any of them to ask, I'm going to go, listen, Steve, you think the Cambrian is 540 million years ago, and Marcus and Paul think it was 4,500 years ago. Did you ever sit down and try to thrash out what the hell happened to all the zeros in between? Can you kind of work that out? Are you telling me it literally doesn't matter that big of a difference between your frames? And the fact it didn't come up, apparently, or didn't bother them, is that plays no role whatsoever in their thinking. They don't think historically.
Well, yeah,
and yet, from a historical point of view, there must have been a sequence of events. Either there was the flood that was taking place, and so there would have been a thing where you would be able to go back to October 23rd, 2350 BC, and you are either before or after the flood, or you got to go all the way back 500 million years to a point standing on the Cambrian beach that somewhere or other there must be a map of time.
Well,
and yet there is zero curiosity. Not one of them think historically.
Yeah, it's
none. I've no kind.
You're absolutely right. I have an example of my own. The Discovery Institute came out with this video a while back. I don't remember what the video is. I remember I saw a clip of their video in a YouTube video, and so I found
secondary.
I found the original video, and eventually I don't remember what it is now. But anyway, so what they did. Anyway, funny backstory on it. Is this woman talking, and she has puffy kind of reddish hair, so she's talking and there's this lab in the background.
Engager.
As it turns out, you can actually buy the lab on Shutterstock. It was hilarious.
That's
Him and Meta did a whole piece on it
over in Seattle. Yeah, she's one of their FIDs.
Yeah,
that are part of their scientific.
So anyways, they're talking. So she was talking about the link between humans and chimps. This 6 million time frame in between our common ancestor with them and ourselves. She said, well, you can't just have 6 million years of evolution, and bam, you have a human. You have to have, what was the term? It wasn't concentrated mutations, although it was similar to that. She basically came up with this term. It was something like concentrated mutations. We'll just say that's what it is for the moment. So I thought, this sounds interesting. I'd never heard this term before.
It's like really concentrated, and then you have to watch out. And when you put the water in, it's like with the little gremlins. You know, don't do it with water, otherwise you'll be up to your armpits in little gremlins and that. Yeah.
Yeah. So what happened was I looked up the term, and it turns out there are no scientific papers outside of oncology with this term. This term does actually appear in oncological papers. As it turns out, it's what happens when a whole bunch of mutagens are hitting the same area of your chromosome, and they're causing a whole bunch of mutations to happen, which is not good at all. It's
yeah, the fun part, the one thing that's so intriguing is, this applies all the way back even to the Cambrian example, when Steve Meyer talks about all the influx of new information in the Cambrian explosion. I'm going, what information? What, homeobox genes, adhesion molecules? This stuff already predates the Cambrian. If you look at just to go from primates to us, new. Are we not tetrapods? Do we have to invent new bones? No. Do we have to invent new muscles? No. Do we have to invent new MHC molecules? No. Do we have to invent new neurons? No. We got the same neuron systems as the primates. The combinations have been tweaked and adjusted, and little mutations here. And we've got a bunch of ALUs that have popped up in our genome, and some of them have inveigled their way into our brains and do a lot of things. And we got our slightly different parasite mixes from our primate cousins. But you'll notice that Gauger or anybody else in that field are remarkably vague as to what is the nature of this new information, concentrated or not. What shifts have to be done? And especially then if you pull that apart to see benchmarks. And this is where you get into the idea of punctuated change, is that you've got populations that start loosening up selection pressures, and you start seeing things kind of looking more interesting, and then they settle down into a new species mode a little bit later on, and there's going to be a bunch of what they're taxonomically vague to work with. That was true with Homo erectus switching into Homo sapiens. That was true of the Australopithecines turning into Homo and all that. You get these iffy zones.
Oh, yeah.
And you're looking at just a slice of that. Oh, jump in.
Oh, no, you go ahead.
So anyway, that's why probably the hardest thing to do, and I'm reasonably confident that there's not an anti-evolutionist on Earth that ever tries to juggle these things in their head, is think about what it is when you got to think about what's going on in a macroevolutionary sequence. You have to think about what's going on, nucleotide sequence, in the cells. And by the way, you have to remember how fast everything is, because you've got these things where you've got the DNA and it's and another thing comes in and takes that stuff. This stuff is happening at blinding speed, absolutely astonishingly rapid processes where mutations are taking place, and then finally the stuff that isn't get used, the cleanup crew comes in and removes all of the crap. That's happening simultaneously in every cell of a multicellular organism, and the cells are connecting together in complex interactive networks where there are also maybe parasites and things that are running around, and all the little viruses and prions and stuff inside of the organism. And the organism is a population of organisms where that process is going on in every single bit of their cell at the same time across a geographic range, and that is interacting with an ecology of parasites and preys and food and things eating them and climate shifts and continents moving. And then you've got to figure that process in that enormous multi-dimensional array long over millions and millions and millions of millions and millions and millions and millions of years in just our own case. Now, one of those little steps has a science literature associated with it, but it's very difficult even for somebody who is pro-evolution science, to try to piece all of that stuff that's known at the moment in together to make this giant multi-dimensional all happening at once in your head to get a clear image of it. I have, in some respects, just actually can come in to help, because they can use ways of heuristics and metaphors and other things to try to get across what's going on. And I'm hoping in my own clumsy way, without any razzle-dazzle graphics, because I don't know how to do that, to get that same notion across. Because evolution is super tunnel visiony. I don't know what it is Ann Gauger thinks, or Kent Hovind thinks, or fill in the blank anti-evolutionist thinks is going on in their map of time with organisms. What do they think is going on? Explain it to me. I don't know.
Yeah, that was, they never think. Yeah, that was my point with the Ann Gauger story. It's like if you think that we share a common ancestor with chimpanzees that did actually live 6 million years ago, and yet you disagree with the process by which we got from that common ancestor to today, what was going on in those 6 million years?
And that's why I put it down as one of the, it's number 3 in my list of magic things, the over-reliance on secondary sources, the limited data set, the map of time, what do you think happened, and then what would change your mind? In any of these areas, that it'll be a different set of circumstances for flat earthers or anti-vaxxers or everybody but Shakespeare wrote Shakespeare's play, that you've got a different set of pieces, but it's still, and so there's always going to be the problem with people. They'll tell you what they don't like. Oh, neo-Darwinism. Ooh, they don't like neo-Darwinism. It's rejected. Oh, no, neo-Darwin. Well, then what the hell do you think happened? And remember, you still got to account for the data. So what do you think is going on? And there's some areas, what's so fascinating is the real science is so exhilarating. When you look at human evolution, you've got to figure out the least interesting parts of the physical anatomy stuff. To get from a hominid to a human being.
My anthropology professor just fell over and died. I just want you to know you killed him.
I know. Yeah, it's in the same way that once you have that basic dinosaur layout, the rest is just, 150 million years worth of interesting variations. But you don't require radically new things. You've got probably the same underlying structural genes, and you've got the kinds of opening plasticity, which means they can vary their vertebrae much more easily and all of that. So now you have the song going on over all these different variations. But it's just a matter of the timing part. The interesting bit, to some extent, some of the things that I think make us human involve something that creationists would pounce on because they're saying, well, that's devolution. It's the idea that certain constraints in our cognitive architecture shut down. I eat broccoli. Why? Because I've deactivated the I hate broccoli gene in my genome.
Well, it's also like neoteny. Would they consider that to be devolution? Because we're like neotenous.
They don't tend to think about it a hell of a lot.
We're like neotenous baby chimps, right?
I know Stephen Jay Gould. It's one of the reasons why Gould is much more interesting to me than Richard Dawkins ever was. He would cover way more of these subject matters than Dawkins would.
Hey,
Dawkins is always he'll punch me in the nose if I ever bump into him again on there. But I can't. Stephen Jay Gould has much more influence on that. Neoteny, punctuated equilibrium, spandrels, those concepts are way at the core, whereas selfish gene, even Dawkins has given up on the selfish gene. He says it's just a metaphor. Well, you didn't sound like that when you were writing your book 40 years ago. But anyway, neoteny, the idea that
killing characteristic. Killing me over here. I read that book a few months ago.
Selfish gene.
It was such a good book. He invented the word meme. He came.
Oh, that ironically.
He came up with that word.
That will be his great accomplishment. Notes of history, science. Because at the moment, it's still hypothetical. But I think the idea that there are some ideas that the brain likes to play with more than others will prove to be a very, very prescient one. Neuroscience is not actually his field. But the selfish gene idea was simultaneously partly true and partly useless, because the lesson that you learn from coming from a Gouldian perspective is that replication doesn't occur in a gene per se. It occurs as an entire organism. And you carry over with you everything in the mix. So an individual gene can skew stuff, and we can find examples of that. But if the organism doesn't reproduce with all of its baggage, your selfish gene ain't going to go anywhere. And if you have problems with other stuff, so it's a unitary package. And there was a very different, I think the Evo Devo point of view is something that pops up out of the people that were trained more in a Stephen Jay Gouldian point of view than the purely gene-centered John Maynard Smith adaptationist paradigm that Gould was screaming bloody murder about back before you were born. And so there's a bit of a history lesson to it. But anyway, neoteny, the idea of juvenile characteristics retained into adulthood. We are in many respects a neotenous ape. We're relatively hairless in the way that an early chimpanzee is hairless, and a few other things. And so the idea, certain cognitive systems can be shut down or modified. You're not having, air quotes, new information. You're having slightly varied regulation of that information, slightly varied application of that information. Is there no new information? Well, if you want to look at it, you could argue that there's no new information in the last billion years. But does that really mean that there hasn't been a hell of a lot of change going on?
Of course not.
Yeah, and the thing is that the people actually doing the work, figuring out about all the fiddly bits, are not the people in the anti-evolution movement.
No.
Gauger and that are minor players on the field. They'll cite little snippets and look at little bits and pieces
or that
of
old
stuff.
paleontologist guy.
Yeah. Well, they got their new paleontologist guy, Beckley, that they just trotted out of the works. And in fact, a creationist lobbed him. Yeah, he's a German fellow, the Joachim Beckley, I think his name is, and he is an insect paleontologist from Germany. He's published a bunch of stuff, he's perfectly fine paleontologist, but he's the closest thing they can get to an intelligent design advocate paleontologist. He's now putting his little signature on the backs of the books. He popped up on endorsing the new Denton book. I think I even called attention to it in Slam Dunk because I'm going, oh, do you really want to sink yourself on this one? Anyway, the fun part is that he's a tiny minor player on things, and as yet he hasn't shot his mouth off on what the hell he thinks. It sounds like he's an evolutionist. It sounds like he accepts the phylogeny of insects and all this kind of stuff, but we don't know because he hasn't actually done any postings at all that I've seen so far. At the Discovery Institute, or they certainly didn't make it onto the Noted Any list. So it's going to be fun to see what he wants to say, what examples he uses. Will he be well-versed in other areas of paleontology? Will he discuss the reptile-mammal transition? I'd like to see him take a whack at that one. And what does he think happened? If he's squishy, apparently he was recently converted to Christianity. And so that puts him into a framework where if you come to the view that Jerry Coyne's version of evolution, you might as well just check it out. It's completely antithetical to science. That there's going to be a natural... Jerry Coyne kind of takes that attitude. That the scientific method and religion are absolutely incompatible, and he's written books and stuff.
Oh yeah, I read Faith versus Fact. Yeah, I remember that.
And it's got merits, but also has got... I've tried to engage Jerry once in a while, and he kind of huffs at me, and then he finally, don't bother me anymore, kid, on the whole notion of the non-overlapping magisteria thing.
Oh,
and I've got a whole...
I might, because I disagree with that too. I think the non-overlapping magisteria is kind of bogus. I disagree with...
Well, you see, pointing out the Gould's, which is the only version they want to talk about. He just gets tunnel visions in on it. Gould's
that was like the only one he talked about in his book.
Religion and science. And I say, no, that's the wrong place to draw the line. There is, in fact, a perfectly legitimate line to be drawn, and it is not between religion and science. It's between decidable and undecidable propositions.
Right.
And all empirical decidable propositions are matters of knowledge, and science figures that out, of which history is a squishy subset of science. Undecidable propositions are normative, they're ethical in nature, they are matters of belief, not knowledge. They are in a totally...
Well, that depends on if you ask Sam Harris. Yeah.
Well, Harris tries to square the circle in his own way. But the odd thing is read Jerry Coyne really carefully, he will say you can't derive oughts from ises. You can't resolve ethical questions based on science. Don't try to do that. And I'm going, that's what I'm saying in my version of NOMA, that you're now jumping across the line to the other side of my line, not the one, because the reason why Gould got so much grief about this, even while he was alive, and legitimately so, is because religions have baggage. And they carry with them a whole bunch of statements about the empirical decidable realm, as well as the ethical thou shalt not eat asparagus or whatever particular belief systems they want to have. So they're jumping across the dividing line willy-nilly, and it's perfectly fair to point that out. And Coyne and company would be saying, no, they're trying to make broader statements on the thing. And I'm going, well, from my perspective, duh. But if you really read Coyne carefully, he functionally agrees with the view I have, but I can't get him to notice it close enough because I'm using an alternate terminology in that. So he's got a Tortucan rut when it comes to this. But I'll dig in my heels on this one, and I have some legs to stand on. I'm building off of William James.
Coyne is still alive, right?
Yes, indeed. He had a conniption.
He's pretty old though, right?
Well, he's a little older than I am, I think. He had a conniption fit because I was trying to mention my website and my work and Tortucan, and it was that one new word too many, and so he just basically says, don't talk about that anymore. And so I can't get any. If anybody out there in Twitter land wants to barrage Jerry Coyne with saying James Downer is an unrecognized genius and you should start paying attention to him,
I'll ask him if he can come on. If I can interview him, I'll ask him.
I don't think he's on cam. He's not like P.C. Myers. He will do occasional things where he'll do cams and stuff with people in various contexts. But I've seen him in things. There was a piece that was done. I can't remember if it was for BBC or one of the other ITV, one of the British channels, and it was about creationism. And they went on this road tour with a bunch of creationists. They took him out to the Grand Canyon and stuff.
Oh yeah, Donald Prothero was in that. And he said like, why couldn't God shrink animals down to the size of chickpeas and put them on the ark? They could fit all of them on there.
Anyway, Coyne was one of the ones in there. They brought him in for the flood. And for one thing, he's not a flood expert. He's not a geologist. He's the wrong person to bring on this. And he's also hasn't read an enormous amount of creationist material. And from a methods point of view, I was actually kind of just annoyed with the fact that the kind of pontifical authority figure position that he was doing, if you're talking with these creationists, what you should be at least trying to do is to get them to examine their own source base and to figure out that they are really not looking at the broad data stream. That if you want to defend a flood geology thing, fine and dandy, do it, but you got to do it with all the data, not bits and pieces of it. And Coyne is not coming at it from a direction that really helps in that area. I've been following another little side issue, well, two areas of interest. One is accommodationism, which is that you should not try to accommodate people's religious faith when it comes to evolution. Just jump and say, excuse me, but it's materialist down to the whole bit, and all of this stuff we're talking about, theistic evolution, is just a cop-out. That's his position, of which science teachers around the country are going, ah! Because this is going to make life really miserable.
Funny story about that. Funny story. Eugene Scott actually is totally pro accommodationism, but also I heard when I was at LSU there was a lecture by the wonderful Dr. Amanda Glaze. Congratulations to her. And so she is
down
very
in the
pro.
trenches.
Definitely. Yeah, she's absolutely amazing. I enjoy her so much.
I follow her on Twitter. Yeah, she's on Twitter. Everybody that's on Twitter, follow her. She's wonderful.
I follow her too. She's wonderful. My girlfriend and I loved her lecture. She was great. But I actually asked her a question because she said at one point during the lecture, she said, "Dawkins is certainly not helping us teachers out there." And I went, and she said, yes. I said, "You mentioned Dawkins, and as someone who's read 5 of his books, can you tell me why he's not helping science teachers?" And so she gave me the whole spiel on accommodationism and how he's totally nixed that. And so,
if you're a religious person of faith but love science, and you are basically told that you have got to junk one or the other, in practice, that's a problem to hurdle over. Everybody has to kind of work this thing out for themselves as a practical matter. And of course, there's a huge chunk of the divide between the empirical science issues, where I would argue that you really do need to dig in your heels, whether it's intelligent design or creationism, about trying to inject designish arguments into the empirical data of evolution, versus all the philosophical and ethical things of whether or not there's some supernatural entity that might be jiggling things or setting up the laws of nature at the beginning of the universe and all of that. Some of those are undecidable propositions. And so to act as though it was as clear-cut a perspective as the anti-accommodationists are, not helping things from a practical level, especially in a world where you got to get school bond issues passed and avoid having the fact of the students rising up with torches at the mention of the nasty E word. So it's not helping the matter much. Now, the other area that he bumps into that's fascinating, Coyne, is the issue of free will. And this is one where,
determinist, if I remember correctly.
Yeah, and it's got layers of validity to it. But one thing that's fascinating is there is a literature that suggests that independent of whether we have free will, that whether you believe you have free will changes your behavior. And that if you look at people who have a belief in free will, that they're probably behaving in ways that are better. Notice I'm suddenly using terms that have no meaning in a scientific context. They are now over in the undecidable proposition category. Mm-hmm. And there's one particular paper that's had a problematic history, and there's been they haven't been able to replicate it. That's the one that Coyne just homes in on like a beeline. But the problem is there are other researchers in this field, and I've been kind of keeping track of all of this stuff.
Are you talking about her paper on elastin?
No. This is on free will.
Oh, on free will. I heard. I'm sorry. I'm in two different. I'm looking at the group chat.
Yeah, brain fart for one of us. Yeah, I was going on the free will. There's a small but not non-existent literature on the behavior of organisms that believe in free will or not. And it looks like that a person who believes in free will is less likely to cheat you, and they do all sorts of things. And if you consider that better, then it's desirable for people to believe in free will, whether or not they do. But here's the deep philosophical problem. Mm-hmm. To change your mind. This was something where another one that is like fighting words. You probably never heard of Mary Midgley. She's still around. And she was a big critic of B.F. Skinner. And so there's a lot of people with a lot of baggage on things. But the ultimate determinists are the B.F. Skinnerians, which are kind of like, like the VHS of psychology now. It's just way antiquated now. We've moved into the neuroscience zone, so we don't need to worry about them and Freud anymore. But you still got acolytes. But anyway.
Before we move on, I wanted to tell you, AJS said something I thought that was very funny. He said, wouldn't it be funny if one day in the far future we would find the cause of the Big Bang, and it turned out to indeed have been a purely energetic form of life that wanted to create an energy-filled universe, and it went wrong for the first couple of 10,000 years when the energy degenerated into matter.
Well,
so it's been getting less perfect
so we
since
need to
then.
sue him because that produced Donald Trump. Yeah, might be a problem with RJ's travel budget, Fino says. Yeah, since my travel budget is zero, and in fact my bare ability to even buy like supplies, like paper and ink, is limited. Yeah, traveling is not easily on the agenda. If I ever get it to the lecture circuit, they'll have to do me a per diem and pay my way and give me a hotel room and a free meal, because that would be required. But anyway, the free will issue is an undecidable proposition, and it involves a series of what are the counterparts of qualia problems. You're familiar with the qualia problem?
No, I'm afraid not.
Oh, this is a far-ranging discussion, Jackson.
Indeed, it is.
In my little card here, well, let's put it. Let me bring out a show and tell. There is the CD of Salome Transformique, and it's kind of showing up as sort of yellowish on your screen there. Okay. Now, are you seeing the same yellow I am? There's a little thing up here with the logo. There's a blue and some red, and there's some red, and there's some black.
I don't know if I've seen
exactly.
the same yellow as you.
not only do we not know, it is impossible in principle to determine whether we see the same colors or not.
Well,
It's intrinsically impossible.
Yeah, yeah. But interestingly, there's a tribe in Africa that can't see the color blue.
Oh no, no, not. Oh well, no, that's a different issue. Is that you can measure the wavelengths of light, you can measure the neural systems, you can measure the optical responsivity of what wavelengths they do, blah, 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 and your little tribe there that obviously doesn't get particular receptors. No, I'm talking about something else. Why does blue look blue? Why does red look red?
What is the sound of a clap?
Does a loud noise sound like a sound and not purple? Why, and we know from synesthesia that you have crosstalk that it can occur in some people. Yeah. Why does ice cream taste rather than hear? All of these are qualia issues. And it turns out, although we can measure scientifically a lot of the nuts and bolts that put parameters as to what you can perceive, and you can tell, for example, that the human brain maps onto language based upon the acoustic range of your mother during the early period of your life, and so forth and so on. You what you're perceiving. We have no way to jump into somebody else's head to tell. And there's literally no way, believe me, philosophers of science have just racked their brain over this to try to figure out how you could devise an experiment. It's worse than trying to measure the speed of light halfway. That you're talking about something that's intrinsically impossible to do. And it's not that it's not physical. In other words, even though I believe as a philosophical position that everything about the qualia as to why I see blue and you see whatever it is you call presumably blue, that everything in it is absolutely mechanistic. There's no way that we can apply science to figure out whether I'm seeing what you are. And that's because it crosses this qualia issue. Now, I suspect the free will issue is popping into the same bit. I went into a lot of this in the Planet of the Apes chapter, because I was going into what cognition is and what self-awareness is and all of that. And so I had to cover it. And there was a wonderful book that was written quite a long time ago. He's still knocking around. He's a Danish science journalist named Nora Tranders, and I think he's still knocking around. He's probably about my age by now. But he wrote a very interesting analysis that built off of Benjamin Lebet. If you are familiar, does that name ring a bell?
I've heard of him.
Yeah, Benjamin Lebet was the one that did experiments, and it's been replicated a bunch of times since, and with more detail as to working out what's going on in the brain. So there's still cognitive literature on this. But if you decide to move your finger, it turns out that your brain has to send the moving signal thing before you make the decision.
Okay.
And you just think you made the decision. You can sort of put a veto on it to say, nope. But the actual priming of the beginning of moving is actually occurring before you are consciously thinking, oh, okay, move. This was throwing off our normal sense of causality, and was also reinforcing the idea that we are like a machine, an automaton, that we just think we have a free will. Another thing that's fascinating is the notion that the brain retroactively puts in the time sequence of stuff. And I've experienced this in my own lifetime. How many times do you wake up and are shutting the alarm off after it's woken you up, but you actually are woken up by the alarm, but you remember it being before you did it? That the brain actually kind of reconstructs reality to suit, and it's got a little bit of time where it decides what took place before what and what did what. Remember, the brain, we know, can confabulate. It constructs a narrative for you. And we know this in the case of people that have lesions and that the disconnect part of their brain from the other side, so that they will make up stories about why they can't seem to move their hand and all of that. There's a whole cognitive literature on this stuff. Yeah, and so what we've got, it's disconcerting to think that we are a machine that are formed of little cogs that are ultimately just chemical squirts happening, little calcium stuff that's being squished back and forth, in the same way that if you looked at an ant colony and all you see are little ants running around, and yet is there like a hyper meta thing? That's another reason for reading Gödel, Escher, Bach, because Hofstadter goes into this same issue of what is a meta level. What is consciousness at a higher level if it's just composed of a bunch of things that are not themselves conscious? What's going on?
I think Dennett did that also, didn't he?
Yeah, Dennett. Well, Dennett skates around the subject. He's uncomfortable with Libet in some ways, and he kind of skirts past it a little bit. And of course, you've got Jerry Coyne kind of skirting around the issues as well. There's an awful lot of skirting going on in this area. To some extent, it's becoming more and more moot as we move into the neuroscience era, when we can see what's going on inside the brains and stuff. But here's the issue, and a counterpart has to do with why we're conscious at all. What is there in this beat computer thing that perceives a movie in the brain where I am seeing you on a screen and you're seeing me on a screen, and we're sitting inside of a room and we're having sensations and we're seeing reds and we're smelling smells and we're hearing sounds as all of these qualia? How is that? And do other organisms seem to have that? It seems as though that you can get up the Mir tests and other things that there's a gradation. You can have a vertebrate that's fairly complicated that probably doesn't really have Tranders would call an eye. Well, and therefore it doesn't seem to notice that there's other things. If you show it a mere picture of itself, it doesn't recognize itself.
Yeah,
but other organisms.
That was in my book that we're working on getting it published. I actually started talking with a lady, so we'll see how that goes. But I still need yours as well as Tony's seal of approval before it goes forward at all. But anyways, so at the very end of the mammal chapter, I talk about what is consciousness and I talk a little bit about it and what does it mean to be conscious, because we would say that to an extent chimps, pigs, dogs, elephants are conscious, but would we say was Moeritherium, was that conscious? Was Paleomastodon conscious? Was we think dolphins are fairly conscious? Was Pakicetus conscious? You know, what is it? Where does the consciousness...
and what is going on in the brain that does that? We're still not entirely sure. It looks as though, and the material that was popping up even in Damasio's period in the 1990s when they were starting to work this stuff out, and it hasn't been fully resolved even yet. But the suspicion is that you've got 3 different brain systems that are self-referential. And that's one of the reasons why everyone ought to read Hofstadter's Gödel, Escher, Bach, because he's talking about the implications of self-referential systems. It's the equivalent of the mirror pointing at the mirror that points at the mirror, reflecting the mirror while it reflects the mirror. You get these feedback loops that don't occur in the absence of that. And my suspicion is that consciousness falls into that category. And the thing that we call free will is the foam on the beer of that complex process. That although all the pieces are mechanistic in nature, their interaction gets to the point where they're now in an area where this eye, this movie in the brain thing that hovers on top, can make, in a reasonable sense, occasional decisions on things. It's totally influenced by its input, but it's not just the sum of the input, because it's beyond that, because it's a self-referential system. And it just drives mechanistic thinkers nuts to ponder that there's something that doesn't fall into the boundary layer there. But again, maybe it's because I had an experience with mathematics, things that don't fit your conventional point. I have blown more materialist-minded engineers' heads when I would ask to point out that some infinities are bigger than others.
Oh yeah,
or my super duper.
0 to 2 is a larger infinity than 0 to 1. Yeah.
No, they're the same size. Both of them have an uncountable number of both of them have a countable number of integers or fractions in between them, but they both have an uncountable number of irrational numbers, real numbers. There's you for you. We'll have to do a whole show sometime on Hilbert's Hotel and the transfinite mathematics. But the one that was really neat for me, there's a thing, I think it's y equal 1 over x. It's a real simple formula. And if you rotate it around the x-axis, you create this like pipette that goes on forever and ever.
Y equals
if you do calculus,
1 over x, that would be like, so that'd be going that way.
Like that.
Yeah.
Yeah. And if you rotate it around to create like a pipette and you slice it off arbitrarily, so now you have a thing where it's got a pipette coming from infinity and it comes up to a point where it's now a slice open part.
Okay. Right. So I can visualize that.
On its side, you got this thing that looks like a little pipette with a circle on the top. If you do the integral calculus on it, you'll discover that it has an infinite surface area but a finite volume.
Oh, that's the
fill it with paint, but the paint won't stick to the inside because there's not enough paint in the universe to do that.
Is that the that's like the disc and washer stuff, if I remember correctly, because we did some integral calculus.
Yeah, there's some really weird shit in mathematics.
Yeah,
or look at another direction. My favorite formula is e to the pi I power plus 1 equals 0. Euler, in fact, tried to prove the existence of God one time by saying that. Well, why is e to the pi I power plus 1 equals 0?
Oh, yeah, I remember that equation.
Constant. Yeah, e is the basis of natural logarithms. I is the square root of -1, which is the basis of complex numbers. 1 and 0 are the multiplicative and additive identity, and they all relate in a simple little formula. E to the pi I power plus 1 equals 0. Now, why is that? Can it not be that? We don't know. Or the fact that you can't do a root formula for a fifth-degree polynomial ever, or a sixth or seventh or eighth. You suddenly reach a transcendence level. There's all sorts of things that your common sense suddenly breaks down. Theory is an area where that takes place. There's all sorts of weirdness. And for the moment, I would say that the science of why we're conscious, and the science of why we have qualia, and the science of why there may be free will is squishy enough that I'm not willing to count out any of those. That if we are an automaton, we're an awfully interesting one. And the other bit is, here was the thing where Mary Midgley comes back in, because she made this criticism about B.F. Skinner, who basically said, listen, we're completely automated machines, we're stimulus response, and it's important that people know that, because if we persuade people that they are automatons that cannot make decisions, then we're not going to have a better society. And you're going, well, wait a minute, how can you persuade an automaton of anything if it's a completely non-conscious system, like a bird in the little stimulus response things? And Mary Midgley, was saying that this is somebody who, with the manly art of self-contradiction, where he just comes along and uses ises and oughts while denying that there are any oughts at the same time. And that's basically the conundrum that any kind of materialist gets into when they're trying to deal with that. Why would it matter if people believe they have free will or not if they don't have free will? Because you can't persuade them that they don't have free will, or that they do, because they don't have free will to make up their mind on it. So that's the internal bit. Gödel would be sitting back there going, this is what is called an undecidable proposition in logic, who, by the way, Gödel was kind of religious. And it's probably because he recognized
I do remember
that there were levels of things.
And a lot of theorem, wasn't it?
A lot of people then can slip a kind of deistic God, at least, through the little portal, and they do. I'm a non-believer. I don't have any God modules knocking around in my head, so I don't have a psychological need for that. But given the nature of undecidable propositions, there's a big turf over there where if you feel like bringing in transcendent figures and all of that stuff, there's enough room to play around with it. And remember, you can't prove or disprove that stuff because they're undecidable propositions. Doesn't mean they're not true or false. And this is one of the ones that just drives people nuts with this analogy that I offer. It's the quadrant. Imagine you've got all propositions that are meaningful, and they're either true or false. And I would contend that all such statements will map onto this quadrant. They will be either true or false, and they will be either decidable propositions or undecidable propositions. And being an absolutist, my opinion about where they go doesn't make the answer right or wrong. They'll be whatever they are, independent of my opinion. Now, at that point, you probably won't have a problem, a sciencey person, to be okay with decidable propositions on the science side. But the moment you cross over to the undecidable side, they just get into a conniption fit at the idea that there could be absolutes that are either true or false in a realm of undecidability. And boy, that just steam starts coming out of their ears on that. It's just hilarious.
Blew my mind.
Yeah. To me, it seems a reasonable thing. Now, if that is true, and remember, my proposition that it is true is probably an undecidable proposition. Aha. But assuming it is true, then we could wonder, could it be that you could therefore theoretically map every individual and or every societal listing of where they're putting the true and false statements on their own personal quadrant? And is it the case that individuals whose quadrant maps up better, and what would you define as better? For example, maybe imagine if you have a situation where they have all of the science material absolutely perfectly mapped in their thing. But over on the undecidable proposition side, they believe that people who are left-handed are evil and should be killed instantly. I would say that even though they have okay on the sciencey front, that viewpoint there kind of corrupts the notion that they may be a little bit dangerous on the other side, or maybe a lot bit dangerous. So now you could theoretically argue, let's look at this in a multidimensional frame. You have societies have in effect a mass of quadrants of all of their component people. Forms the nexus about the behavior of that society. Do societies where overall the heuristic of the mappings of the quadrants matches the true quadrant more than not? Will those do better than ones that not? Or can societies do really well even if their quadrants are completely discordant with the actual true quadrant, which I presume to be the case based upon an assumption?
Sounds
Is that blowing your brain by now?
Well, that sounds kind of Aristotelian to me.
Yeah, well, or Platonic. I'm a bit of
Platonic.
a
Sorry, yes,
Platonist.
Platonic.
Because one of the things that I've said for years, suspicion that the universe is what mathematics does for a living.
Mm-hmm.
That everything in mathematics actually maps to something in the universe, and everything in the universe is ultimately mathematical in structure. And I can't prove it. It's an undecidable proposition. But it's looking like that whenever you think to draw a line in the sand, that mathematics can go here and no farther, everything else is abstraction. Some guy is going to find out an example of some complex biological phenomena that actually operates on the basis of this mathematics. And it's happened over and over and over again. And quantum theory bases itself on, you can predict new quantum particles, subatomic particles, based on group theory that James Jeans and the bunch back in 1910 thought was absolutely useless.
That goes way over my head. I'm a poor little biology guy. You know what the physicists? You know what the physicists say? If it's not physics, it's stamp collecting.
I had a well-rounded education in both high school and college because I had a bunch of professors who were very much interdisciplinarians. So they believed in you've heard of C.P. Snow. Two cultures and a second look.
Ooh,
what? I better put that in there. People need to look that up. I'll put that up on the thing. C.P. Snow, Two Cultures and a Second Look.
I don't know. I think
this was way back in like 1960 or so.
I think it was interesting.
He was a physicist. He was a physicist, I think, by trade. And he was saying that there was a problem in education because it looked like the liberal arts people and people going into government and stuff were scientific illiterates.
Yes.
And that the sciencey kinds didn't care a damn bit about Shakespeare or the music and philosophy stuff. And he said, this is bad. That you need to be equally versed in the whole repertoire to be a well-rounded person and to be able to make decent decisions. And I would be saying, from my decidable, undecidable thing, that in effect you need to be able to have that broad range in order to have a good sense about what's on the decidable front and what's on the undecidable front, and to be able to make intelligent decisions based on it. Anyway, Snow, there's constant reiteration. Snow, I think, is dead now. But the philosophy issues that he comes up with are still as valid today as they were before. I was steeped in what would be now called cross-cultural fields, both in high school and then when we got out here to Eastern. I was in an interdisciplinary course here at Eastern, where it was about German culture from the foundation of the German Empire through to the end of World War II. And it was taught collectively, a professor from the music department, a professor from the art department, a historian, a scientist, and a political scientist, and there would be lectures on all the different things that were going on in quantum physics and advanced art and Mahler's music and atonality and cubism and Nazi and the development, and it just
I had an English class like that.
Yeah, and that stuff was astonishing because it weans you off of the nothing buttery thing of where you just are looking at a tiny little slice of stuff and forgetting that science is done by human beings and it exists in culture and artists we're in a state that I think it's starting to change. There are some upcoming artists and rock musicians and others who love science, and they want to try to find ways of conveying that love of science through their art.
Yeah, it's actually very interesting that we're talking about this, because there are really two things I want to say about it. For one thing, I think a lot of people are moving away from liberal arts, or are taking a not so favorable view on liberal arts, because I've actually seen books at LSU. One was titled "In Defense of Liberal Arts." It was defending the idea of liberal arts, which is kind of interesting to me because I've never really particularly had a problem with it, but I guess there are people out there who do. But the other thing is, because of the dirty P word, postmodernism, we're actually
the venereal disease of the late 20th century.
We're actually getting pushback against science from some liberal arts people, for example, people who are studying what you would think
to put it gently, effing stupid.
Do what?
Which is, to put it gently, effing stupid.
Yeah, it's King Crocoduck's doing a series on it. He talks about them called the new Lysenkoists, because they are saying science is cultural, which it's palpably not. And
it's like and you get a bit of it, the so-called hoax, SOKL. To some extent, there were a group of liberal but still sane physicists, usually, who would be pointing out some of the wacky things in postmodernism. And in some respects, some of the intelligent design movement function like postmodernists, and basically saying that there's no really true things other than stuff that you can get from revelation. I'm going bullpucky. But the thing is for me, I couldn't imagine a world in which I'm not just as familiar with science fiction movies and Mahler symphonies and quantum theory and paleontology and all that stuff all in one thing, because it's all part of a unified package. That this was an attitude that you tended to find in, like, say, 1840. If you look at the early period of the Romantic movement, it's surprising how pro-science they were. And you found people, Thoreau was a science geek. And you have the same kind of material, that the differentiation that you tend, to some extent, there's a bit of cyclicism to it, but it's way easier for people in a camp that the things they don't want to understand personally don't matter, and therefore, oh no, it's unimportant. We don't have to bother about that. And I straddle the line in both of these domains, and I refuse to give up on any of them. I think you illuminate. Give you a neat example from history and art. Frank Capra, the guy that directed It's a Wonderful Life, he basically retired in 1961 because his last movie, he was having trouble with the actor and all that, and they just said, hell with it. If I can't control the damn thing, I'm not going to make movies anymore. But he lived for years and years and years. And he was on the Johnny Carson show, the ancestor of Jimmy Fallon, for all of you young kids who have no idea who the hell Johnny Carson was. And he was talking about why an artist can tell you things that the historian can't. He said that if you got a time machine and you brought Queen Elizabeth I from Britain, and you had her read every history book written about her, she might very well say, my secret is safe. No one ever found out. But if a really insightful artist were to do a thing, and she were to watch the films and artwork about her, she might very well have to say, oh, that's the difference between the insights that an artist can do, in a way, is why Shakespeare is still dramatically powerful, why Hamlet still has impact, because it's the universe contained in a play, and it's got issues to where, to this day, actors can decide how they're going to approach Polonius and Claudius and Hamlet.
Yeah. They just
did the same words, put nuance into them, and create your own universe based on that. And art can do that in a way history can't.
I took a theater class last semester because I had to get my art credit out of the way. Darn snow. Anyways, so in my class we watched different portrayals of the to be or not to be speech,
Oh yeah,
And
yeah.
so we
I think
watched
I may have
one
seen that.
that was like black and white. We watched one that was like
Yeah,
early color.
I bet even there's a section in there where there's a German actor saying "Sein oder nicht sein, das ist die Frage." That's so. Oh, well, what's his name? Oh God, I can't think of his name. German actor just died. He was in Deep Impact. I'll think
But
of
it
it
also
eventually. Yeah, I think I've seen that.
it even had
Yeah,
the guy who played, oh, he was one of the doctors. I can't remember what his name was or is, because he's a fairly young guy.
yeah, Daniel Tennant
Anyways,
probably.
yes,
The
yeah,
big
there we go.
Shakespearean
Yeah,
actor.
yeah, and so it's all these different guys playing this one speech, just this one speech, and they're all doing it in these different ways.
And it's a whole universe of it. I think that if I remember it correctly, because I think I've seen this as well. It was on PBS years ago. I think they have sections in there with Orson Welles, who's great, big, fat guy, and that really serious actors or directors or both will approach these things. It's a universe of psychology. You have to make up your mind about what you think about everything that you bring into that story. And that's true of why interesting science fiction is so fascinating. And that's why, in some respects, Star Wars was operating at a more juvenile level than Star Trek, because it's just not thinking through quite so much, and it's aiming at less. It's basically space opera with lasers instead of horses. And although Lucas has a pompous streak, he isn't nearly as sophisticated as he would like. Whereas Star Trek at times was really tackling a lot of bigger level issues. They often shied away from some things and pulled back from them. But genuine science fiction is always about us. And that's why if you look at Rod Serling's stuff, or for that matter, Planet of the Apes, what he wrote the script for, the original version, this is about humanity. This is about science and culture and prejudice and all of the things
and
that are
monsters
humans.
at 20,000 feet.
Yeah, yeah.
Or 20,
and so I've told people that I've literally got almost all of my philosophy of life from the Twilight Zone and Rodgers and Hammerstein musicals. I didn't need anything else. I never had to worry about the Bible. I can get all the philosophy you need from those, because you discover that just because an alien looks weird doesn't mean it's a threat, but sometimes it's a cookbook. And that the idea from Rodgers and Hammerstein that I'm not better than anybody, but I'm just as good. That's Oklahoma. You have to be carefully taught your prejudices. That's South Pacific. That there is genuine applied ethics and philosophy and decency showing up in Rod Serling and in Rodgers and Hammerstein. Deuteronomy and St. Paul to 10 Ways West of Sunday. And I would not want to give up on any of that, or the sheer rhetoric of knowing what the language is. In order to understand people's positions, if they're coming from a religious perspective, you need to know their background. You need to know the works. If you're just looking at the Bible as something you snark at, no, you look at it as a piece of literature. The King James Version is wacky, but it's also a very decent translation for the 16th century, 17th century, and it still reads very well. I'd hate to imagine them doing a revised standard version of Handel's Messiah. I'd rather they stick to King James and the original material in there. It works rather nicely. So you never have to give up on stuff. Instead, you want to improve as much as you can. Jump in.
Oh, I was gonna say I have to go to bed. I've got to wake up.
Oh, yes, it is way late there, and it's 9:30 here. Thank you very much for the discussion
tomorrow.
And I hope we didn't bore everybody. We certainly had a broad-ranging discussion of stuff in there.
RJ, you never bore us.
I'd say if you can get C.P. Snow and read that, you'd probably find it in the library. And by all read William James's The Will to Believe. You can get that online. That's an easy speasy. In fact, read everything of William James. God, that man was brilliant. Oh, he had it way sharper for somebody in 1870 than he had any right to be. And never forget that don't give up on the liberal arts. Don't give up on the sciences. Don't give up on arts and music, everything. Know history. You've got to know. In order to know what stupid decisions not to make, you need to know what stupid decisions people did before. And you need to know why you're doing what it is. So the whole piece comes together. The more operations you can use, I'll offer one of the examples that I use. The notion of Tortukans and non-overlapping magisteria is stuff I've taken from The Nightmare Before Christmas. It's a perfectly good illustration of some of the limits of scientism. Anyway, there's some food for thoughts. Thank you very much, gang, for listening over this long period of time at the old guy rattling on in the thing without any damn graphics, without fancy schmancy stuff. I don't know how long I can keep that trick up. Well, thank you very much, Jackson.
Thank you very much, RJ, for having me.